Again, what were the two conversions that we were using for moles? Okay, Avogadro's number, which is what?
6.02 10
times 10 to the 23rd particles. And again, it's up to you to decide which of the type of particles you're working with, right? Is all equal to what? 1 mole. All right, so that was the first conversion that we were using. Okay, what was the second one?
Oh, the 2.
Is it molar mass?
Okay, molar mass, right? The one that we get the atomic masses from the periodic table, right? This is also referred to as the gram formula mass. So a lot of times you might see it abbreviated as GFM, okay? That one refers to atomic mass, refers to molecular mass, refers to molar mass, right? So there's a lot of terms that they use for these, right? But again, these are coming straight from the periodic table. And that's all equal to what?
1 mole.
1 mole. Okay. So these are the two conversions that we were using, right? So if they said you've got 3 moles of, let's say, helium, can we convert that into particles?
Yeah.
Okay, what do we always start off with?
Right.
With,
Is that after the 3? Is that like M?
Moles, sorry. Ugly looking moles there. So again, how do we start the conversion? What do we always start off with?
what they first give you.
Okay, what they first give you. So we're given 3 moles of helium, right? So we put 3 moles of helium times, which one of the two conversions are we going to use?
The gram GFM.
Okay, why would you want to use the GFM one?
Because we're using the mass of helium.
Where? Where is it talking?
Mole of helium.
Okay, but it's going moles to particles.
We're going
Okay, then we're using the Avogadro.
Do you understand why?
Because we're using part. We're trying to find.
Exactly. Right, so that's why you always have to look at what they're giving you, right? They're giving us moles, we're trying to get to particles. We don't have to go to grams, which the gram formula mass would give us.
Okay.
Okay, so we will use Avogadro's number per 1 mole. What's going to go where? What has to go on the bottom?
1 mole.
The 1 mole, right? Because that's the only way it's going to cancel out. So that's how we know we don't have to flip this one. We're going to leave it the way it is, right? Because again, depending on what we have to do, we might have to flip this one. But in this case, we don't because we want the 1 mole on the bottom. So 1 mole goes on the bottom. So what's going to go on top?
6.02.
Okay, so Avogadro's number 6.02 times 10 to the 23rd. And what? What units?
Atoms.
Okay, again, we're looking for a type of particle. Which type of particle are we going to use in this case? Why an atom?
Because
Right? It's only the element, right? Anytime it's the element by itself, that's when we use atoms. Okay? So what cancels?
wait, don't we put helium or atoms?
Okay? So moles cancels out moles, right? And now, since they're both on top, we just multiply them, right? So we've got 3 times 6.02 times 10 to the 23rd. I think. 1.806 times 10 to the 24th.
Yeah.
Is that what it shows you?
Yes, sir.
What units?
In atoms.
Atoms of what?
Helium.
Yeah. Again, you always want to indicate the substance that you're working with, right? So in this case, we've got atoms of helium. What do we have left on the bottom?
1.
Just 1, right? So we don't have to worry about putting the 1 underneath it. We don't have to worry about dividing by anything. We're okay with this? Just reviewing, just in case.
Do you want us to do it with the E or with the 10?
The times 10. The E is for the calculator, the times 10 is when you're writing it up. Okay, like I said, last time you were first using it, so I was allowing the E, but now you know what the E is for. Okay? All right, so in that case, we use the first conversion, right? Another one could be, let's say, 54 grams nitrogen. And we want that in moles. Again, what do we start off with?
Is this one?
Okay, you always start with the information given, right? We're given 54 grams. We never start with one of the conversions, okay? They always have to give us a number to start off with. So in this case, we've got 54 grams. 54 grams of what?
Nitrogen.
What's the symbol for nitrogen? What's the symbol for nitrogen?
N.
Anything special about nitrogen?
It's one of the diatomics.
It's one of the diatomics. Okay, so how should we represent it? This is important for a reason. Numbers, I think 12 and 13 on the previous problems, you had to consider this. Okay? Just a warning to go back to those two. I think it was 12 and 13. I'll have to check again. All right. Which one of the two conversions are we going to use in this case?
This one.
Why would you want to use the GFM one?
Because we're talking about
Trying to solve for a mole.
Right? But we've got grams. So, right? That's your hint right there. We're going to have to use that particular conversion. Okay, the other one was moles and particles. First conversion was moles and particles, right? Okay, so we're using the second one, right? Where's the 1 mole going to go?
On the bottom.
Okay, so let's go with the bottom. If we put mole on the bottom, is it going to cancel anything? No.
And it's on top.
Okay. So again, it's easy to set these up because there's only one way that they're going to cancel. Okay? So 1 mole is going to go on the top. So that means the gram formula mass has to go on the bottom. What is the gram formula mass for nitrogen? Okay, 14.01. Let's stick to 2 decimal places, just so everyone's consistent, right? But 14.01 is for a single nitrogen.
So we need to.
What do we have in this case?
Multiply by 2.
Okay, so that's why it's important that we write the symbol for it, the element, because we need to check if we're dealing with diatomics. Anytime we're dealing with a diatomic, we're going to have to double the atomic mass. So instead of 14.01, it's going to be 28.02 grams. Okay, and that's the reason I like calling it, instead of anything else, I like calling it gram formula mass to remind you that those units should be in grams. Okay, what cancels out? Okay, grams cancels out grams. Have we reached the units that we want? Problem is asking us for moles. Are we at moles? Right? So what do we do now? Okay, so we're going to multiply the top. So it's going to be 54 times 1, right? 54 what? Moles of our nitrogen over what? 28.02. Any units on the bottom? No, we canceled out the grams. So in this case, what's the last thing we have to do? Divide them. Okay. 1.92? 1.9, 1.93? Sorry, I ran out of space here. Moles of nitrogen. Are we okay with that? Okay, so those are the two types of problems that you were doing before, right? So one of the first things you're going to have to do, I put in some diatomics to see if you recognize them, right? So now you'll have to go back to check if there's any diatomics. Okay, now the last thing for the problems for today. So far we've only used one conversion or we've used the other conversion. Is it possible to use both conversions? Yes, it is. All right, so let's consider something like if we have 100 grams of sodium oxide and we want that in particles. Okay.
What would this be called?
It's still the same thing. We're still doing conversions for moles. All right, so 100 grams to particles. How do we start the problem?
Right.
Okay, we start off with what they give us, 100 grams. 100 grams of what?
Sodium.
Okay, what is the formula for sodium oxide?
NaO. Wait, you gotta balance it. So.
Not balanced, you got to cancel the charges.
Na2O. But the 2 is a substitute.
We agree with this?
Yeah.
This is the reason we have to know how to write formulas, right? Because it's going to be important when we do this stuff. Okay, so which one of the two conversions are we going to use?
We're trying to find.
The first one we're going to use is
Okay,
grams
so
formula mass.
what are we starting off with?
Grams.
Grams. So which one of the conversions are we going to use first?
Yeah.
All right, so we're going to have to use the GFM one first. Okay? And again, it's gram formula mass, right? So we need to look at the formula. So what does our formula tell us?
There's 2 sodiums.
So there's 2 sodiums, so what are we going to have to do?
Multiply the sodium by 2.
Okay? Multiply sodium by 2, or just so we can see it, there's 2 sodiums, right? Yeah. So we're going to add those 2 together. And what else are we going to add to it, though? The oxygen, which is 15.999, right? So since we're trying to stick to 2 decimal place, that third 9 rounds everything up. So we've got 16.
What do you do for the other one? I'm talking about for.
No, because sodium stops at 22.99.
Oh,
If there was something after that 9, it would do the rounding or whatever. Okay. And again, depending on the periodic table that you have, some periodic tables show sodium as 22.98 something, and then the 8 gets rounded up to a 9. Okay. I don't know. What does your periodic table say for sodium? The what?
22.990.
99. So, yeah. Okay. So 990? So, yeah. Okay. So are we okay with this? So what is the gram formula mass then for sodium oxide? 61.98? And what units is that going to be in? Grams, right? Again, when we're doing the gram formula mass, right? Gram formula mass, it's going to be in grams. Okay, so now we can start our conversion. So where's our gram formula mass going to go? Top or bottom?
Bottom.
Okay, so our 61.98 grams goes on the bottom. What's going to go on the top?
The mole.
Right? So again, it's always the gram formula mass per 1 mole. The 1 mole never changes. So the 1 mole is going to have to go on the top.
Grams cancel.
Okay, so grams cancels out grams. Have we reached the units that we want?
No.
Have we reached the units that we want?
Just say no.
Right now, what units are we left with? Moles. And the problem is asking us to get to particles, so we're not done yet. So
This
What's-
is two-step.
what's the next conversion that we're going to have to use? Yes, exactly. We're using both conversions. All right, so we're going to use the Avogadros per 1 mole. Where's the 1 mole going to have to go in this case? Right, because this 1 mole is on the top, right? So for those to cancel, we need the moles to go on the bottom. So what's going to go on top?
Formula. Avogadro's formula.
That's not a formula, it's just a number.
Uh,
Avogadro's number.
Avogadro number.
6.02 times 10 to the 23rd. What kind of particles?
Or no.
Okay, so 3 types of particles. We've got atoms, but that's for elements. Somebody said molecules, but molecules are used for what kind of compound? Covalent. Is this a covalent compound? No. Ionic. So what are the particles? Ions.
So what are the 3?
Atoms, molecule.
Atoms, molecules, ions. What cancels out?
The bone moles.
Okay, moles cancels out moles. Right? What units are we left with? Ions. Are those the particles that we're looking for? Yes. So, final thing we have to do is multiply stuff, right? So we have to multiply the top, and we have to multiply the bottom, and then divide these. So on the top, we've got 100 times 6.02 times 10 to the 23rd, which gives us 6.02 times 10 to the 25th,
Yeah.
Yes.
I think. And that's going to be ions of what? Na2O divided by what?
61.
All right, 61.98 times 1, so we've just got 61.98. Right, any units on the bottom?
No.
No, they got canceled. The grams got canceled, the moles got canceled. So, final thing, we just need to divide these through. So, we should probably get something times 10 to the 23rd?
Yes, sir.
Okay, so 9 something or what?
9.7.
9.71 times 10 to the 23rd. What units?
Ions.
Ions,
So,
sodium oxide. Bless you. All right, so did you have compounds in the first 14 that we did previously? Okay, so if you had compounds, you might want to go back and make sure that your gram formula masses were done correctly. Okay? Also look for any of the diatomics. Right? Once you've done checking those, start the next 7, which are
why
these where we require 2 steps. Okay? Hopefully you didn't do it in pen, right? All right. Let me know if you have questions.